To add a new antenna study, right-click on the project name and choose Antennas. Give it the name of meander line. Click on the Frequency Sweep tab. Enter 4.7 GHz for the start frequency and 5.2 GHz for the end frequency. Enter 51 for the number of frequency points. No need to check the other tabs. The default is adequate for this application. Click OK. A new antenna study is added to the HFWorks manager tree. Let's apply the material for each body. Right-click on Airbox to apply air. Similarly, you can follow the same procedure to apply material to all other parts. Since we applied materials in a previous study, just drag and drop materials from the previous study with meander line to materials in this study. Let's apply the necessary boundary conditions. We have two antenna elements. So, we need to set two excitation ports. Port 1 is excited and port 2 is terminated with 50 ohms. Right-click on Boundary Conditions and choose Port. Apply port 1 on the circular face of Arlen. It is a simple wave port. Click OK. Click on Boundary Conditions and choose Lump Port with an impedance of 50 ohm. Apply port 2 on the other face. Click OK. Click on Boundary Conditions to add perfect electric conductor boundary. Choose the bottom face of the substrate which presents the ground plane except the meander line slot and the inner and outer faces of coaxial part. Apply perfect electric conductor boundary on the antenna patches which are printed on the top face of the substrate. We are left only with the radiation's boundary conditions. Click on Boundary Conditions, choose Radiation and add all the outer faces of the airbox. To create another study without meander line, just copy the above study. Give it the name No Meander Line. All input parameters given to the meander line study remain the same, except the meander line slot. Edit the perfect electric conductor boundary. Add the meander slot face to the list of existing faces. It is equivalent to eliminating the meander line because the ground place is all metallic now and has no slot. All the pre-processing is now complete, and we are ready to run the studies. Right-click on a study name and choose Run. Solving will take time. Let's instead examine existing studies that were run previously. After the run is complete, Results folder is created and contains different type of results. Circuit Parameters folder contains the results table and 2D plots. Antennas Parameters folder contains the far-field results such as gain, directivity, efficiency, etc. Electric field and magnetic field folders contain the near electric and magnetic fields in the entire model. Port fields folder contains the electric and magnetic fields on the ports. Loss density and total loss folders contain the volume and surface losses inside the structure. Double-click on the results table. It contains all circuit parameters for all frequencies. Click Close. Double-click on the far field results table. It contains all antenna parameters for the central frequency. Right-click on the Plots folder and add a new 2D plot. Choose All from Source. Choose S21 from Parameters and click Add. Click OK. The plots of S21 versus frequency appear for the meander line and no meander line studies. S21 at 4.9 GHz is around 7.5 dB and 26 dB without and with the meander line, respectively. The S21 graphs clearly show that adding meander line slots greatly improves the isolation between the antenna elements. Another metric to verify the isolation is the plot of the near electric field. From the electric field folder, we can create different types of plots: fringe, vector, or streamline. To show the fringe plot of the electric field, just click on the electric field icon. The magnitude of the electric field is color-coded, where the red color is the maximum and the blue color is the minimum, as shown on the legend on the right side of the plot. To animate the electric field plot, right-click on the electric field icon and choose Animate, as shown. To show the vector plot of the electric field, just click on the second icon with the vector symbols, as shown. To show the section plot of the electric field, just click on the thread icon with the section symbols, as shown. To animate the section field plot, right-click on the section field icon and choose Animate versus Section Cut, as shown. Similarly, you can plot the magnetic field, the port fields, and the loss density, as shown. To plot the 3D gain pattern, just click on the polar plot icon, as shown. Last but not least, you may generate a report that summarizes all of your work. Right-click on Reports folder and Generate. Customize your report and choose either HTML or Words format. Click OK. Let's now compare the electric field plots with and without the meander line. This one belongs to the antenna without meander line. This one belongs to the antenna with meander line. From these two plots, the near electric field plots on the top plane show a reduction in the coupling between the elements if a meander line is used. Hence, the meander line is recommended to be used for reducing the coupling between elements in antenna arrays.